25. 26. Let's go. I guess I lose. Wait, shit. What? Yeah, but technically you showed up. That's true. That's true. Okay. Before we get started, what do you want to learn about? You can tell me by going, yeah, by going here and see, I carefully hit it so that it says last week of class quiz, and then you freak out, and then you click it, and it's a survey. So you don't lose any points for filling it out. Okay, let's ask another question. Are we having a final? Raise your hand if you did it. All right. You're the reason why there's a final. No, just kidding. But do it. I can't force you to do it, but do it. Yeah, thank you. Okay. Yeah, that's an image, right? From JWST. Yeah. All over the background are basic stars. Well, this isn't a real picture. This is an artist's conception. So we cannot see the surface of any star. Every star that you've ever seen in an image, except for the sun, appears as one pixel, as one point. And what happens is that light spreads out and it appears larger, like it's a circle. That's an illusion. Stars are too far away, and our telescopes are not big enough to resolve them, let alone to resolve something like that. Does that make sense? Okay. It's 4 o'clock. Who is happy to actually be in this class right now? Who wants to learn something today? Okay. Who wants to go completely off script and do whatever? Okay, so we're gonna do one clicker question. Okay. And that way I can do two things. Okay, the first thing I'm gonna do is I'm gonna determine who's here. And the second thing I'm gonna determine is decide what we want to do today. Okay. So you're gonna answer in your clicker question whether you want to, 1, leave, 2, do class as normal, 3, do class on something fun. So the options are 1, leave, 2, do class as normal, 3, do class on something fun. Yeah. 1 is leave. I have 0 class as normal. Okay. What? So 1 is leave. 2, just do the lecture that I've already prepared. 3, do something different. Is that it? I think there's like 30 people in here. I have 26 respondents. Oh, you forgot yours. Okay, all right. That's pretty close. So 0 people said do it as normal. 12 people said they want to leave. 14 people said do something new and fun. So if you want to leave, you can leave, I guess. And I'll just do something fun instead. We can do any of those other lectures that I pointed out. So we could talk about life in the universe. We could talk about, yeah, like basically whether or not there's aliens. We could talk about the timeline of all time. When did everything happen? We could talk about radioactivity. Why do some atoms fall apart and some don't? And how do you make atoms? We could talk about the history of the space race. Like, how did we leave the Earth and why did we decide to do something so stupid? Any of that sound interesting? Hold on. Okay. So for people who are deciding to stay, now you get to pick life in the universe. What was the second one? Time of all things. Radioactivity and like how that happens. Like, how do you make elements? And then what was the last one? What? Alien was the first one. First one. And then the last one was space race. Okay, we have a runaway favorite. Yeah. Oh, I see. Yeah, we have a runaway favorite. All right. Space race was 4. You are one of 2 other folks. Okay, and if you don't want to stay, you're welcome to not stay. I thank you for coming in today. I'm sorry that I waste your time, but it's not my fault. I got like basically a slew of emails today and yesterday that were like, I'm so sick. I was like, oh fuck, should I cancel class? And I was like, at least some people were like very honest. Because what I want is honesty, right, in this class. Like if you email me, someone's like, I'm on vacation. I was like, don't worry about it. You know? Okay. So turn in your homework if you have it. Let me pull up aliens. I call it aliens, but it's really not aliens. If you believe you're about to read about aliens, you're wrong. Okay, what's that? Satellite dishes, right? Yeah. So this is how we receive information from satellites. So if you have watched the film Contact, right? That's a good one. You can watch that over the Thanksgiving break. Okay. Okay, hold on. Let's do another one. Okay, that's interesting. No one likes yes. Not one vote for yes. One person liked yes, but not for long. And everyone else thinks that maybe like not, maybe they're watching this. So that's what we'll get into today. Okay. We're going to talk about a couple different things, some concepts first, and then we'll kind of talk about like all of it. Okay. Hopefully this works. I want to introduce you to something called the Fermi paradox. Okay. So paradoxes usually mean that something seems weird, right? And usually paradoxes are resolved because you didn't understand the physics behind it. So like a paradox is presented and everyone gets really upset and it turns out you made a mistake. Okay. So currently we have something called the Fermi paradox. And it says, so this is not a real image, this is a different spiral galaxy, right? And this is us. And that's like the whole galaxy, and there's like 100 billion stars in it. And the question is, why don't we see any signs of intelligent life when we look at nearby stars? Right? Lots of them. We're here. Where are they? Okay. So this is the timeline. So if you want to go to the timeline lecture at some point, it looks like this. It's very straightforward. So universe was created. Some planet somewhere, maybe 8 billion years ago, was formed. And then 4 billion years went by, and that's the Earth. And then we're here. Right? So if you think about that, then you might run into a very natural solution, right? Which is like, what if stuff doesn't live for 8 billion years? So here's the planet's birth. That's the Earth's birth to now versus like some planet X. And then maybe like it got to where we were. And then there was 3.6 billion years of development and never died. Right? So this is the length of time between the T-Rex's extinction, 62 million years, and today. Right? So that's 62 million years in between. So that could be a potential explanation. Right? To answer this, we asked this question. It's called the Drake equation. It's very like hand-wavy. It says, okay, we need to calculate a bunch of stuff to figure out how likely it is that we're alone in the universe. So the first thing we have to calculate is we want to know how many intelligent civilizations are. Because I don't want to talk to microbes. I can barely like communicate with like cats, right? So God forbid it's multicellular organisms. And that's the answer. I want the number of intelligent civilizations. So what do I have to do to make this? How do I have to know? Any guesses are fine. Yeah.
Any artifacts? I know the Aztecs and stuff like you could say someone like, or like even the Egypt, some of their.
I'll go ahead and skip to the very end. All created by people. Yeah, humans have never been visited by aliens. I'll just skip right to the end and I'll explain why. Yeah, sorry. If you want to leave now, then you're also welcome to. What information about like life and science do we have to know in order to answer how many intelligent civilizations are? Yeah. Because they had a lot of time, right? This is a really important thing to remember. Just because we're on TikTok 24/7, right? You have to remember they didn't have shit else to do. And the people who were rich paid them in beer and food to do things. And when that's your whole fucking life, and you have generations of stonemasons, like people would start building the pyramids, and 100 years would go by of building it. You can do a lot of shit in 100 years when you have 20,000 people who are all very good at something, right? And if the only thing you're good at is chipping rocks, you're gonna be real good at it, right? Like masterful at chipping rocks. Okay. Okay, so you need planets. Good. That is one of the things that we will have to find. Another? Yeah, you need an atmosphere, we think. We need something to put the life in, right? Because otherwise, you can't just be floating in space. Anything else? You need water, probably. We think we need water. We also think we need an interaction between water and minerals in order to form life. And you need free available energy. So for example, what I mean by that is that we take sunlight, we turn it into grass, and then we eat the thing that eats the grass. Right? Unless you're a rabbit, right? And then you directly eat the grass. So you need free energy, you need interaction between water and rocks, and you probably need something to protect them, right? A biome. Okay. Here's a bunch of stuff I wrote down. The first thing I said was, you need to know how many stars there are. Okay. And then you need to know how many of those stars have planets. And then you need to know how many of those have an environment that's suitable for life. Yeah. Yeah, right. So that's a very good question. Like, how long will the Earth be good? Right? And that kind of goes back to that earlier point. What if we were looking back at some planet that formed 8 billion years ago, and the window for being livable is short? right? So that's the next thing we have to say. The fraction of suitable life of planets where life actually appears. And you can make estimates about this, right? So for example, on the Earth, how many planets in our solar system, how many planets have life? At least one, right? And how many planets do we have? All right, between 9 and 8. So if you're like a physicist, you would just go ahead and make that a fraction of 1 out of 10. And that's probably a dramatic underestimation, right? So now this is like, let's say you have 1,000 stars and every star has a planet. You have 1,000 planets, but maybe all of them suck, right? So maybe you only get like 90 planets that can harbor life. And then if they can harbor life, the next step is, do they harbor life? Right? So for example, we talked about Europa. We said that there's water, there's free energy, there's interactions with rock. What if we don't find any life there? What if it's really hard to make life? We don't know. We only know with the one data point we have, which is that life is here. Yeah.
Wouldn't it be different, say like, because we're looking at like, they have to have the same materials that are like, similar to Earth, but gonna be different, like, it's gonna be changing, like, they'll be adapting to something different than we are, so. It's not.
Yeah, this is a very good point. So one of the questions is, we're looking for carbon-based life.
Yeah.
And one of the major questions is, should we be looking for stuff that's made of stuff that's not carbon? Right? But we don't know how to make that. So that's one of these like really tricky questions, because how do you do a scientific test for something you don't understand? If you want to go down a rabbit hole, you're welcome to look up something called the shadow biosphere. This is a real Wikipedia article. And in the shadow biosphere, it talks about what if there's organisms that live with us that we can't detect? Like we can't detect dark matter. Kind of a weird hypothesis, an unscientific hypothesis. So as scientists, we kind of have to steer away from it. But biologists, they figure out, can we try to detect things that we wouldn't be able to do normally, right? Okay, so we have a fraction of planets that are suitable for life. And then we have the ones that intelligent life. Okay, so notice that's like a hand, right? So you have to make art and you have to like create like intelligence. Now, some would argue that my dogs are intelligent, right? So I had the question civilizations. So you have to go one more step and you have to be able to build shit. My dogs can only, take shits. Okay. And then you have to fraction in how long this all lasts for. Because if it only happens for like 1 million years and then everyone dies, then your window is very short. If it happens for billions of years, that's great. Right? Okay. And all of those lead to numbers at the bottom. Let's talk about the different types of civilizations that we could expect to find if we look out into the universe. There is a scale called the Kardashev scale that says there's 3 types of civilization. We are not currently at step 1. Step 1 is finding all of the energy that comes from the sun and using all of it on the planet. So that would be like using every single piece of the surface that is possible for let's say in the rainforest here, you would have solar panels everywhere. And in the ocean, you might have like wave machines. And then on the edges, you might have wind everywhere, right? We're not there yet. We use a very, very small fraction of the total energy available from the sun. But if you wanted to have a really, really big population, you would need to use more and more energy, right? Which country uses the most energy in the world? US. Yeah, US does. Which country has the largest population? China. Good. Or maybe India, I forget. One of those two. All right, double check those. Now, what would happen if everyone in India or China had the same quality of life that we do here? Energy. What? We'd be screwed. Yeah, we don't have the infrastructure to provide them with energy, right? So most of the energy in the United States goes not just to like heating people's houses, but into making everything that we love into the internet, shit like that, right? There's industrial applications for energy. So we might find that as a civilization, you want to harness all of the available energy on the planet. That's the first step, right? What happens when you run out of space on Earth? Yeah, go up, right? Okay, so you build something around the sun. This is a hypothetical object called a Dyson sphere. It's really sick, okay? You build a giant solar panel, but now you trap the sun inside. Okay, so on the inside here, you would have solar panels, and on the outside, you would have radiators. And folks are looking for signatures of these. Okay, because these Dyson spheres would still have planets going around them, but they would be very bright in the infrared and very heavy like a star. Now, if you're very heavy like a star, you should be large enough to make light, right? Because you have all of this matter that's squishing together and turning it into fuel, flame. So they haven't found it, which, we haven't looked very far, but okay. So now you use up the entire star. You use all the energy. Now what do you do? Keep going where? Yeah, next star. Okay. So this is a type 3 civilization. Starts at the home planet, goes off, tries to grab these other planets, and then from there, they build a network that they can harvest all of the energy of all the planets. Pretty cool, right? Or is it? Dun, dun, dun. No, I'm just kidding. Okay. So this is giving us a little bit of a framework to begin to think about this problem, right? Because we don't see this. We are not at 1. We don't see any evidence of 2. We certainly don't see any evidence of 3. And so the next question is, what's going on? Okay. This is we literally coffee. You know what this is? Okay. So on the timeline, we have to understand something called the Great Filter. And we have to ask the question, is there a filter? So the way that this hypothesis is based is we state, now this is a hypothesis, so we're going to see if it's testable. We state that there are no other civilizations. Okay? And that there are 9 steps necessary for a galactic takeover. And somewhere along those 9 steps, there is a choke point. There's a point in here that filters out all the civilization. And the question is, are we headed there? Are we about to encounter it? Or did we somehow make it through? That's the big question in the Great Filter here, right? Because this could tell us a lot of things. This could tell us that we're about to die, like maybe the proliferation of nuclear weapons always kills off every civilization. Or maybe we got lucky and we were like the only ones to make it through the stage from a monocell to multicellular organisms, right? Okay. So let's do the 9 steps really quickly. The first one is your planet good? Okay, so here's Earth. And the question is, can I have liquid water on the surface? If you have an atmosphere, etc. And so what you see here is that for big old hot stars compared to little stars, the place that you might be able to have liquid water on the surface as a fraction of the starlight, there's a lot of these planets in here, right? And these are all planets we actually do know about. So these are all potentially, they call them habitable worlds. Okay? On Earth, there's a little timeline here. I want you to see that this happened 4.5 billion years ago, or 4,540 million years ago. I'll just keep that updated at the top. Okay? We know this happened. Good. We see other planets doing it. That's not where the filter is. No question about it, right? Okay. And then, boom. Life arises from non-life. About 3.6 billion years ago, life just showed up. And the oldest life in the universe, or that we know about, us here, is this stuff. You know what that is? What? Not quite coral. It looks like coral. Not quite. They're called stromatolites. Okay, you can find them. They're still there. That's obviously a real picture. This is in Australia. And that's how we can tell how old they are, because you can go find them. Okay, so these stromatolites basically arrived as soon as it was possible. The things that have to happen for it to be possible are things like not having a magma ocean, having a temperature that's cold, having liquid water on the surface. So we think somewhere in the billion years after the planet formed, it cooled off enough, and almost spontaneously life arose. The definition of alive, according to biologists, I'm not a biologist, is that you have to be able to do these three things: metabolize, eat, self-repair, heal, and replicate. Right? Okay. At some point, we don't understand how this happened. This is a big old question mark. Talk to any biologist and they tell you that they understand it. Let me know, because I don't believe them. This is a Nobel Prize winning discovery. You find out how this happened. So there's this example, right? Have you ever heard about this like lightning in a bottle experiment, where someone took like a glass ball and they put a bunch of amino acids and they exposed it to lightning and said, "Oh, we get life in there." Turns out it was like really contrived and like designed in order to succeed. And they've had a lot of difficulty reproducing it. So that sticks in like our public consciousness, but we have a big issue right now, whether or not life started in something like this, in like tide pools, where material was allowed to accumulate and then form life, or if it started like here in the deep floor, sea floor. The only problem with this is like it's really hard to accumulate stuff at the bottom of the ocean, because it's the bottom of the ocean. And like if I'm a little amino acid over here and then one over here, the chances that I bump into each other is very small. Whereas if I'm at the bottom of a tide pool, the chances of these two amino acids bumping into each other and like wrapping and becoming DNA, it's better. Yeah.
Isn't it like our knowledge about the deep ocean like really limited in general?
No, not as much as this, right? Because we go look at the places that are cool. It's a lot of places that are just not that cool, right? They're just like empty. You got to look for places that are hot in order to have free energy. Here you have all the necessary things. The free energy is given by the geochemistry. You have water. And you obviously have the minerals interacting with the water, right? Whereas on the left-hand side, the same thing is true, but it's from sun. This step, we'll come back to. Okay, ready? Next one. Okay, also don't quite understand how this happens. You get single cell organisms. That's one cell. There's like cilia, and then they like move around, and they like, or something. I don't know. Biology. That happens like right away. That is this. Spontaneous life, single cell organisms, we think hand in hand. But then they become complex. That's about 2 billion years ago. You can tell this is a cell because, what? Where? Oh, shit, it's right there. Yeah, good. All right, so that's how you can tell it's a cell. That's the only thing anyone learned in biology, right? Mitochondria is the powerhouse in the cell. Good. These are very complex. What? Okay, all right. Fine. Let's be real. Not have fun in fun class. Okay, so this is an animal cell, and this is a complex animal cell. This is still one cell, right? Complex single cell organism, right? That takes 1.6 billion years. Simple cell, complex cell. Okay, now we're seeing some of the problems. Okay, then, you get sexual reproduction. You go from this sort of process where you are not just cloning. This is really important because this introduces variation, right? Yeah, now we start with the idea of genetics. Now, it's not quite genetics in the same way because genes may or may not be expressing in this stage of biology, right? Genes are an object that may have evolved later, but this is when we start to think of the very basic form of that. And that probably also happens when they become complex, or maybe 800 million years after, right? A lot of bumping into stuff, right? That's how cells learn. And then you get the cutest multicellular organism. What's your favorite multicellular organism? Yeah. Oh, did you say you? Okay, that's a pretty good one too. Okay, it's the tardigrade. Okay. Whoa, don't look like that. That's cute. It's like a bear. It's a space bear. So this is an organism, multicellular, and these are probably the first ones. It's a great example because this guy absolutely rocks it. You can throw him into space and he's fine. And he can live in space for a long time and come back and be fine. Not all cells are that dope. If you threw me into space, I would die. So this example here, you know, the condition's probably not that harsh, right, for the tardigrade to have developed. He's not the first one that developed. They got really good at being robust. The first ones probably were not so robust, right? And that happens about 1 billion years ago. 1 billion years ago. Okay, and that's it, right? Now we've gotten up to where we can come from, and we're going to just draw a distinction between that and the next step, which is that you have to use tools. Notice how long that step is. Okay, when did we start using tools as all life? About 4 million years ago. Okay, my dog apparently still doesn't know how to use tools. A crow doesn't know how to use tools. I sometimes know how to use tools. Okay, we got real good at it, stabbing and killing stuff, right? So in order to use tools, you need like pretty advanced intelligence, right? You need to be able to usually communicate, systems of language, we think. Maybe that's not true. And then once you've built tools, then you can make big tools. Okay. So this is us. You are here. And of course, there's all these steps beforehand, right? And there's only going to be one. I told you there's 9 steps. I told you there's only one after. It may be that we underestimate this, but in the great filter theory, we have to start with the things we know. We can't possibly predict all of these future steps if we haven't experienced them, right? So this is where we think we are. You know what this is? It is a rocket ship. Good. Which rocket ship? The rocket ship that it is the Upgoer 5. So this is one of my favorite comics. So this is a comic called XKCD. He just does like nerdy shit all the time. Randall Monroe. And he has this recurring theme where he takes really complicated diagrams and turns them into only the top 500 most common words. Okay, so that is actually the Saturn 5. But Saturn is not in the top 500 most common words. So then it says Upgoer 5. And if you look very carefully down here at the bottom, it says fire comes out of here. So this is like giving you an explanation for how we got to the moon in 3 stages. This is the stage 1. This is stage 2. That is stage 3. And then this is the Eagle lander. And that is where they sat in the command module. So they strapped themselves to 191 feet of fuel and then lit a match, essentially. Didn't always work. Yeah, pretty cool. Took them 8 days to get to the moon. If you like moon facts, I have so many moon facts. when they sent the Apollo 10 astronauts to the moon, they didn't give them enough fuel in case they decided to go rogue and land when they weren't supposed to. So they said, if you land on the moon, you won't be able to get off. Because you forget that the people who were flying this were crazy people. I mean, they were like test pilots, right? So they were like the boldest, cockiest people in the world. That's why they got selected to be astronauts. They knew that they were launching. And they also knew that there was a possibility that they may never get stuck on the moon if they weren't selected for the next mission. So they had to like put into place placeholds so that they didn't go rogue and land when they weren't supposed to. They didn't give them enough fuel. Okay, so that's us. And then we didn't go to the moon ever again. 60 years ago, we did it. And then everyone was like, whatever. It's not exactly true. We're trying to go now. But the public basically lost interest once we flew to Russia. Yeah.
I think everybody has the same question. You know, like UFOs and stuff, or if you want, is there, you know, are there UFOs hiding there? Anything like?
We're gonna get there. We're gonna get there. I mean, I previewed this at the beginning. We have never been visited by aliens. And I can say that with absolute certainty. Know that it's disappointing. What?
Is that what they told you to say?
If I was making enough money to be bought, oh my God. And we did talk about the theory of conspiracy, right? Because like, one of the things that's the most interesting is, look at how much I like to yap. You think I can keep my fucking mouth closed? I'm not, like, they're not paying me enough. You see what I'm wearing? I was holes in my sweater. You think I'm holding back a global conspiracy? No. Like, people would be ratting that shit out so quick to DMZ, and you never see it. And we'll talk about why you never see it, right? It's very easy to look around and be like, oh, like, it doesn't fit my narrative of like what would be cool. But once you hear the alternative explanation, then you're like, oh, okay. That makes a little bit more sense why I haven't been contacted personally about aliens. We're trying to contact you about your extended warranty. Okay. And then that's it. Just at some point, you colonize all the other systems, right? Okay. So when we think about the great filter theory, okay, we have to place it. And we have a couple different options. So the first is that we're rare. Okay? That these are these random steps, and we passed the big one, and we survived. But everyone else is not. And maybe there's another one out here that's catching up or getting there. They haven't made it yet, right? That life is rare in the solar system. Another explanation could be life is really common, but we're the first, right? Remember that early planets didn't have enough metals to form like terrestrial planets. They didn't have the building blocks, carbon, nitrogen, oxygen, to make life, perhaps. So maybe you have to wait long enough to get that material to make these beautiful bodies, right? That could be an explanation. What's the third explanation? What? It's worse than that.
They're ahead of us.
Yeah, we're fucked. That's exactly correct. The filter's ahead of us, right? And maybe there are some that get through and like we're quite here, like totally unoblivious to the fact that we're about to be tweaked, right? Okay. So these are potential explanations for the great filter, right? Because we don't know where in that process it is. There could be steps past step 8 that I haven't gotten into, right? Because we don't know. Is that fair? Okay. So now I want to give you some potential alternative explanations for why we haven't been contacted. Okay? This is a very important distinction because this is talking about how does life arise and whether or not there is life. But we should really think about, okay, let me go into each of them. The first one. What if they did and we were this? These are the stromatolites, right? Would you try to contact them? Like you go and you look and you're like, oh, that's boring. And then you move on. So maybe just because we got overlooked. Right? Because how long have we been interesting? Maybe 4 million years. And life has been around since basically 3.6 billion years. It's like a fleck of time, blink of an eye. Okay. Or we're in a boring part of the galaxy. Right? Maybe the whole galaxy has been colonized, but we are quite far from the center. So maybe we're like, you know, a rural pit stop and no one comes to visit. Right? They found in nearby other stars that were cooler when we look like stromatolites. Right? Or the idea of physical colonization is maybe primitive. Maybe we don't understand the idea of colonization well. We've only seen it done over and over on Earth that we expect that's normal, that you should want to conquer all. But maybe advanced civilizations figure out that's a bad idea or something. Okay. So these are fun, right? You like those? Okay. What if we're using the wrong tools? What if they communicate with something other than light? Have you seen the film Arrival? Also a great film. It talks about what would happen, how would you communicate to an alien if you weren't able to speak English? Anytime you watch like an alien film, they come down, first of all, they always land in the US. Right? And then they always speak English. It's like, I have people who I know who have lived here for 30 years, they still don't speak English very well, right? Like, how did aliens figure that out? That doesn't make any sense. I guess they died, so maybe they have advanced technology. But maybe we're using the wrong tools. Maybe they exist in a form of light or they interact with matter in a way that we don't understand. That's very possible. We talked a little bit about the shadow biosphere, but it's also non-scientific, right? Because we only have the tools that we understand. So that's a really hard thing to say. Well, you can always sort of cop out to that. That doesn't mean that it's not right, right? You can believe that if you want. You're welcome to believe whatever you want. It's just not science. Okay. Or, you know this one? Please tell me you all know what this film is. The Matrix, yeah? What if we're in the Matrix? Oh no. So there is non-negligible fraction of people that believe that the universe is a simulation. Yeah.
Isn't that like a 50-50 chance technically?
No.
It's like.
No. That's not how we do chances. Chances being yes or no is not a chance, right? So if I drop this, it'll either fall or it won't fall, right? Is that a 50-50 chance? No, because it's definitely gonna fall, right? Okay, so there are rules, right? And the fact that people think that the nature of our reality being misunderstood, there are people who are trying to figure this out seriously, and there are people who get really high and then talk about it at night, right? Or on Twitter, right? And those are not the same people. Okay? Yeah. Elon Musk is a moron. Okay? The first time that you learn that Elon Musk is a moron is when he says anything having to do with something you know about. So he sounds really smart if you don't know what he's talking about. And the very first time he started talking about Mars, I was like, oh, he's a fucking moron. Right? Okay. We can go into that in a lot of detail, and we will. But here the important thing to think about is, how do I test it? So here's the reason why people think this, and not just because they're bored. So if you look at the very smallest scales, you find out that, you know, it's not this piece here made up of atoms, right? And atoms are made up of electrons and protons. Good. Can I break an electron down? Is there anything inside an electron? Not inside an electron, but inside of a proton, there is. There's little things. Can I break those down? No. So there's a stop. There's a limit. And it also turns out that there's a scale. There's a really important scale. There's a length that's really important. Okay? And it's ubiquitous through physics. So people say, man, that sounds a lot like my computer graphics. Okay, that scale is like a minimum resolution for the universe. Okay, that's a way to interpret it. It's not right. Okay, it looks similar. I make analogies about food all day that doesn't make them real, right? They're analogies. Okay, does that make sense? There are very serious people working on this. The conversations you see online are not serious. You do not see these scientists talking about it. They don't know how to have a conversation like we do, right? Like we're cool. I mean, maybe you are. I'm trying. Okay. All right, next one. To your point. No, that's up there. That's up there. It's in the realm of possibilities. I work for the state government. Maybe my clearance isn't high enough. Right? Like, I don't make a lot of money. They didn't tell me. Maybe they only tell the very highest, but you know, Trump's already been in office once and he tweets everything. He tweeted the word confefe, right? And like, you think he would have found out about aliens and not immediately told us all? So this one, I don't think is possible. Okay. Yeah. What is the point of Area 51? Yeah, so here's the interesting thing, right? Okay. One of my favorite things, and don't use this rudely, okay? So I'm going to teach you a phrase, and you can't just go around saying this at Thanksgiving, okay? But the phrase is, everything is a conspiracy when you don't understand how it works. What? Okay. So one of the problems is, yes, we don't understand what's at Area 51, so that leaves open questions. We put a lot of money into it. We don't get answers. And so naturally, we're curious beings. We create narratives. We create things to understand the world. And when we have an absence of information, we fill it. Right? It doesn't mean it's right. And in particular, the US spends how much money on defense? Something like $700 billion per year. We have more F-35s, which is the 5th generation fighter jet, than any other nation. And we've probably already built 6th generation jets, and they probably live there. And we don't want people to know about them. So we have all these hearings on unidentified objects, and they're following our subs. No, that's the US fucking with the US. Okay? We are so good at military that we keep secrets from the military. Okay? The reason why we would do this and the reason why we would say this at all is because let's say we have adversaries in the world. We have people in Russia and North Korea who don't treat us or think of us as friends. They have weapons pointed at us, we have weapons pointed at them. We don't want them to know what we're capable of, because that would motivate them to make their bombs better. So we'll just say, oh, you mean tracking our nuclear subs? We could never track your nuclear subs. What are you talking about? We can definitely track the nuclear subs, right? Okay. Does that make sense? It's not as fun an explanation, but that $700 billion is not going nowhere. Okay. This one's one of my favorites. They know that we're here. They're just watching us. They're just like, you know, like, has anyone seen the Truman Show? Yeah. They're just like, what if like the whole Earth is reality TV for aliens? That's kind of fun, right? Gives your life like way more meaning. Like, that's why I try to do like funny things while I'm alone. Yeah. What was there? I don't watch black and white television. Okay. That's fun. Harmless, mostly. Right? Maybe they come and adopt us as pets. I really don't love working sometimes. That'd be great. Okay. Let's remember why we're thinking about this, right? So we're looking up at the night sky. We're seeing lots of stars. And we're asking, why is no one trying to have fun with us and talk to us, right? And we're like, we're here. Let's dance. Maybe that's dumb. Fish don't scream. Okay? As they swim in the ocean, they do not go around saying, hey, I'm a fish, because there are sharks. And sharks like to eat fish. So maybe the reason why we haven't heard from anyone is because they're smart enough to be quiet. And we're not. Maybe we're too naive to realize that broadcasting where we are is a bad idea. So if there are bad actors, that is to say, a galaxy or a civilization in the galaxy, maybe the very biggest one, right? Like, or other several ones, went around and snuffed out ones until they just were quiet. Right? This is my favorite. And similarly to this one, perhaps there is one Thanos-like civilization that just exterminates everyone as they go, uses up all the resources of that star, and then leaves it for dead. Right? That's also very possible. Last two less fun. Right? I told you that some of them would be fun. I told you some of them would not be fun. Okay. So no conversation about aliens would be complete without colonialism. Did you think that would happen? Okay. Everything comes back to colonialism. It fucking sucks, bro. Okay, so unfortunately, the reason that we think about aliens at all is because we have ingrained this idea of take everything over, right? Because that's how we started off this conversation about civilizations. We started off by saying that a type 1 civilization would use up every square foot and every piece of available energy on the Earth. And then they would run out of space and they would take over all of the energy of the star. And then they would run out of space and they would take over nearby stars. That is the act of colonization, right? Now, it's not the way that we think about it, but it's the way that it's been ingrained to think about it. So when one asks you why they should colonize, you should ask, why should you, right? Instead of, why not? So people say, why do you want to go to Mars? Why not? That's not a very, good answer. Because I can is a horribly dumb answer, right? It's a free country. It's a free universe. I can just go wherever I want, right? Are these well thought answers? No, they reflect privilege. I can because I take. I want to, so I will. It's a free country for me. It's my right to take your right, right? Each of these statements has a hidden understatement, okay? If I go to space and I use resources to go to space, let's say I use NASA resources to go to space, I take those out of the funding of other projects, right? Now that doesn't mean that we should defund NASA. Listen, I get most of my money from it, okay? But when you have this, oh boy, right? So on the right-hand side, that's Elon Musk, and this is my friend. He did this talk, fantastic. It was Make Mars Great Again, and it was the ethics of Mars colonization. And if you really want to understand how this would work, you need to watch Total Recall. Total Recall, and I'm sure there's other sci-fi that get to this, but Total Recall 1, very funny. Arnold Schwarzenegger, amazing. Okay, and what they do is there's a mega corporation on Mars. And what they do is they take the resource that's the most important, air, and they privatize it. So that you have to pay for air, and so you work to buy your air. If you haven't seen it. It's smart, right? That's what capitalism does. You have a resource, you commodify it, and then you make people pay for it. So even though, he has this great idea of going to Mars and sending people there to be on vacation, who works at the resort? What are their incentives to work at the resort? Right? Everything has a layer as long as you ask one more question, right? And it's about the ethics of the situation. The Mars Lorax, yeah, that's a very good point. Okay, so let's have a look here. All right, here is the version of Mars that they want to present to you. Let's go, right? Let's go. That's who? Matt Damon, yeah, classic example. I forgot what the name of this director is.
Ridley Scott.
Ridley Scott. He also, I believe, did Saving Private Ryan. No, maybe not.
Yeah, he did a.
He did alien. Okay. There's a funny tweet I read once that like think about how many films he's had to be rescued in. Saving Private Ryan, Interstellar, The Martian. Like he's just anyway. You want him back, right? Will Mars look like this? Maybe. Maybe it will. I don't think there's anything wrong with going to Mars as a scientific expedition. There's a lot of really important questions that can be answered, right? And the thing about space is it tells us about our place in the universe. So one of the questions that we might have about Mars is there is liquid water on the surface, or there was, and then it disappeared. Did life spontaneously evolve in that period? Because we could look for fossil records. Now, do we need to have a hotel there while we do it? That's the ethical question, right? Because answering this question about life and whether it arose on Mars benefits all humanity. Is having a hotel that only rich people can go to on Mars benefit all humanity? Some people might argue that that's something to strive to, right? I think that's a contrived argument. On the left, will it look like this? Probably not. Because behind this is certainly like an underclass who surfaces it all, that you can't see and doesn't see the light, right? So here's humans. In case you're curious, when you as a Homo sapien went out into the world, and we can argue about the timing, but please let's not. Let's just assume that this is right, even though many of it is still under debate. So there's Homo sapiens, and there's Homo erectus in the light color, and there's Homo neanderthalis. So they went up, and they went into Europe, and they went into Southeast Asia, and then they went up. Why didn't they want to go up here? Well, it's because it's cold. Dumb to do that unless you have no reason to. They finally had a reason to. They had this land bridge. They're like, oh, sick. And then they came down here and they found out a lot of really cool things about the Americas. They only went to Madagascar in the last 1,500 years. I think it's remarkable. As the same with New Zealand. Getting to islands is hard. Okay. But they did like explore all of this. Soups. And we see evidence of it, archaeological evidence. What happened to Homo erectus?
Breathe them out.
Yep, they're murked. Yeah, we killed them all. And the very few that we didn't, there's just a little bit of your DNA, but very, very little. What about Homo neanderthalis? Yeah. Murked and yeah. So as Homo sapiens has propagated around the earth, they have destroyed every other massive species. So there used to be here like wild tigers and lions, and we see like they coincidental to the introduction of humans, the destruction of massive animals. Because we're really good at using spears, right? We figured out how to use tools, we just did it. We were hungry and we ate, right? So that's how we kind of think about this idea of colonization, is resource utilization. In fact, we see that at the very smallest basis. Okay, what do fungi do? What do mold do? It moves around looking for food. And then it uses up the food and it goes somewhere else to look for food. Right? That's the motivations for everything that we see as far as like species moving, migrating. Now, of course, species create art and there's beauty in the world, but that's not the process of colonization. Okay? This was the justification for the manifest destiny. So we have the right to. It's our country, right? Why shouldn't I? It's a free country. What? God said so. Yeah, that's a good one. We love that one, right? So is this a valid explanation for space travel? Because I want to? No. Because of course, colonies will not provide good working services. So if you live on Earth and Mars is the colony where they're extracting XYZ to send it back to you. Or if Earth becomes the colony of the Mars elite, one of you will be subjugated, right? You'll destroy those places. You'll subjugate the humans. Right? Okay. It's perfectly in time for Thanksgiving. My timing is so good. Okay. This moron said that he wants to die on Mars, just not on impact. He said that he would make it accessible to travel to Mars, that one just could work off their debts. Quote. Okay. It's pretty good, right? It's literally, I'm telling you, go home, watch Total Recall. It's fantastic. I think he watched it in like designing who he wanted to be. Is like the main villain, same person. Okay. I mean, it's really cool. So this is, you've all seen these videos, SpaceX videos. You want to see the reusable launch vehicle? Okay. So basically what they've done, SpaceX, and we can talk about the politics of this when we get through this. They made reusable launch vehicles because using them once is very cost ineffective. So if we can just fill it back up again, attach the rocket to the top, awesome. Now we can bring the cost of spaceflight way down. He claimed that the goal was to get, to Mars. Is that what we're planning to do? No. His goal is to provide Starlink and to use Starlink to power internet, domination over the world. Telecommunications is a lot of money. Okay. So let me show you here. This is super sick. They can land them and they can simultaneously land them. I mean, that looks like sci-fi, right? That's like what you use to see like Star Wars that land together. We can do this. And they have big ones, the Starship, right?
Mars?
Yeah, SpaceX CEO Elon Musk speaking at the South by Southwest conference in Austin, Texas. Musk was asked what the first humans to travel to Mars will experience on the red planet.
Difficult, dangerous, good chance you'll die. Excitement for those who survive.
He's signing you up for that. Isn't that great? Okay, and here's my favorite one.
You sincerely think that we should go to Mars, like that men and women should go to Mars.
Yeah.
Why do we want to go to Mars? It's uninhabitable.
It's very inhospitable. That's true.
It is. Like you have to be in like domes and everything, and you're just breathing.
Initially,
Initially?
yes.
Really? How long before we could turn Mars into some place where we could live?
It is a fixer-upper of a planet. At first, you're going to have to live in transparent domes, but eventually...
Yes, we're going to be huffing each other's stank.
Yeah, but eventually...
Okay, hold on.
Transform Mars into an Earth-like...
He's trying to say, why would you want to live on Mars? He's like, well, at first you would have to live in domes, and then you could finally heat it up enough. You could like heat up the atmosphere enough by dropping bombs on the ice caps, nuclear weapons on the ice caps, so that it was like warm enough for you to live there. Okay? So this is a while ago. This is the first time I realized, fucking moron. Because he was talking about what I know about, which is planets. When he was talking about cars, I don't know anything about cars. I don't know anything about batteries. I was like, he's a genius. Right? And then he started talking about rockets and planets. And I was like, ooh, fuck, no, he's not. No, he's not. Okay? I was bamboozled. Okay? So here's the question. Is Mars habitable in the long term? No. It is small. And its atmosphere is escaping today. You add new atmosphere, it boils off. It's a bad investment. Okay? Is using nuclear weapons a good idea? No. Nuclear weapons produce something called radioactive fallout, which causes birth defects. Okay? So this is Chernobyl. You guys didn't want to learn about today. Okay? It's a nuclear reactor that melted down. Okay? And as it melted down, big old plume of radioactive material that they could detect here. And they're like, something happened. Something bad happened. Scientists were like, something bad happened. And they go and they look, and this is where they find all of this radiation. Okay? Takes hundreds of years sometimes for it to go away. At least 100, right? in these locations. They can still find it. And it leads to birth defects. Right away, like in this region, you can just die right away. So one of the craziest things about radiation burns is that, okay, I'm gonna go on a little tangent. Hopefully I have time. Chernobyl, if you picked up a piece of the graphite, a piece of the radioactive graphite, it'd be very hot to the touch, you'd drop it. And you'd be like, oh, ow, that hurt. But the problem is that now the radioactive material is in your hand. And so it begins melting your hand from the inside. And so, for example, firemen were going in to put out the fire. They would be wearing clothes. That clothes would be on them. They're not touching the fire. The radioactive stuff hits their clothes, gets embedded, and causes their skin to melt off again. So many, many people died. That doesn't mean we shouldn't use nuclear reactors. Okay? You should watch another film called Chernobyl on HBO that has to do with the physics. Only 6 episodes, 4 episodes, 6 episodes, something like that. Very quick, fun. HBO does a good job. But bad stuff happened there that was not the reactor's fault. Reactor was good. People were bad. Okay. So this is a stupid idea too. So don't put nuclear weapons on Mars. That's dumb. Okay. And it's true that the cost has been coming down. I don't know if you could really argue that this is a good idea. There's not enough stuff there. There's not enough gas. There's not enough water under the surface. You can't remake Mars habitable. You know what you can make habitable? Earth. Earth is fine. It's right here. You don't have to bring anything anywhere. Imagine if we spent all of the money on the so-called mission to colonize Mars on making Earth better. We have enough money for people not to be hungry. We choose not to do it.
Isn't there also plenty of things we can do that we don't do that is free? Like just taking better care of the earth in a lot of places?
Sure, but there's a lot of companies out there who are actively trying to make things worse, right? So we should stop doing those too. Right? We have to do a lot of things. There's no one answer, which is I think one of the most horrifying things about looking at the world. Do you want a simple answer? And that's why Mars seems so nice. Just go to Mars. The backup. This is great. Okay. All right. Where did the idea of aliens come from? So in the 1860s, there was the first telescopic observations of the surface of Mars. And on the surface of Mars, they saw something that looked like canals. And they exclaimed to the world, hey, I think there are people there. What they were seeing, it turns out, was rivers and streams. But they looked like pathways between cities. Like there'd be dark spots and then there'd be light spots and there'd be lines between them. And so people really thought there were people on Mars for like 50 years. The late 1800s, they just assumed that people lived on Mars. And there are papers in the literature of people being like, I think they're trying to signal us. Because they saw clouds and they thought that they were signal fires. Okay, I swear to God, 1894, there's this paper. And I can show you if you want to see it. Okay. So this leads to this whole idea of like Martians, green men who live on Mars, right? That's the first place that it comes from. And then there's a book that's called War of the Worlds. Okay? And the craziest thing about this book is they fucking read it on the radio and they didn't, like, if you just like clicked on, you didn't know they were reading a book. So they thought that this was happening, like they're reporting on this thing. And suddenly people become obsessed with the idea of alien invaders. And guess what? If you look at the locations where aliens have been spotted, I don't know if I created a map of this. Like look at this, Google for yourself locations of the so-called like alien visitors. It's US. Like alien sightings happen in the US and England. That's fucking it. Okay, this is an obsession that is deeply American and English speaking. Okay, so we can go into the psychology of it later because we don't have enough time. Oh, also,
Would Martians remain loyal to the Earth? Fuck no. Okay. Well, first thing that would happen is it took 200 years for Americans to be like, get the fuck out of here. We're not paying for tea. Okay. You think they're going to be subjugated for hundreds of years to work for the Americans? No. In like 1 or 2 generations, they won't feel like humans anymore. They'll feel like Martians. Right? And they'll revolt. So the idea is cockamamie through and through. Okay. Does that answer most of your questions? You see why the ethics of going to space doesn't make sense? Do you see why aliens haven't visited us? No, because likely, if they did come to visit us, they would come to exploit us. They would come to take everything. Right? What's the most valuable resource on Earth? Water. We have lots of it. It's still here. That's how you know they haven't been here, right? We don't see any evidence that suddenly the water levels dropped like 300 feet unexplainably when an alien came by to refill, right? This is not a 76 station, right? They've never been visited as far as we know. Because if they had, they would take the most valuable thing and go. Getting to the next planet is really hard. And you would not do that and not spend billions of dollars or whatever their currency is to go somewhere to just say hi and leave, right? Like you don't drive, well, maybe you do. It's kind of beautiful, right? You go to like a national park and then you leave. But that's an exception to the rule. Okay, we don't think that that's happening.
Would other countries just let us have Mars?
No.
Like, I don't know, like.
No, of course not. Of course not. But no one is seriously talking about colonizing Mars. When you hear Elon Musk talk about it, 1, he's an unserious person. And 2, nothing that he's saying is the thing that actually he wants to happen. He's using Mars as a pretext to fund SpaceX, which is a private company, which is, don't get me wrong, doing great things. But their main mission is not to get to Mars. It's to build infrastructure for low Earth orbit, right? Telecommunication, refueling the ISS, right? Spy satellites. That's the goal. If you can shoot weapons from space, you can. It turns out that's a very lucrative place because guess what? We spend $700 billion per year on defense. Imagine if you had a laser from space that could shoot. That's a lucrative idea, right? So they sell you, go to Mars, amazing, and what they're doing is making weapons. Okay. Is that helpful? I don't know if that diatribe was too much. I'm happy to answer any other questions. It's not a great point to end on, but questions, comments, concerns? There's no clicker questions in that section, so yeah. The Fermi paradox at the beginning was talking about why we look around and see all of these stars. You see, like, you think probably hundreds of billions of stars in our galaxy, and yet no intelligent life is contact. Right? And we think that that's resolved by one of my 9 other answers, or we're rare, or we're the first, or we're screwed. Yes. Right? So there's the great filter interpretation, which is that everything's getting filtered out, or there's these 9 other reasons why we might want to be quiet. Right? And they're all valid until we find out which one's right. Yeah.
So we were talking about being one of the possibilities being that we're in like a really rural area of the galaxy. Could it be that we're in the galaxy's equivalent of a national park? Like, don't talk to them.
Yeah. That's this one. This is my favorite one, right? Like the Truman Show. Yeah. So and maybe it's protected. Like I see this conversation a lot of like, maybe we're like pets. Yeah, or something like that, like just like out on the outer fringe.
Like they're observing their own history.
Well, interestingly enough, so one of the motivations that people talk about this, one of the serious motivations, not the stupid ones, is that you could simulate, if you were dealing with a sufficiently advanced
civilization, they may run into something similar to what we have found, which is like, how do you save the climate without ruining the economy? Right? How do you have this like, because that is probably the most important question of our time, right? Can a species save themselves from self-induced extinction? And that could be why they're simulated. Right? That I would believe, not just for shits and giggles, right?
They're watching our simulation right now, like, no.
Well, they're trying to figure out whether or not like because they'll look at that and they say, oh, look, the solution. You know, in like 80% of the simulations, they figured out how to do this. Maybe we're in a simulation that is failing. We don't know. Right? But if you, so for example, if you run a weather model, we don't just run it once. We run it like 90 times with slightly different inputs to see how well it ends up. If does it end up here? Does it end up there? Does it end up here? And then if most of the models converge over here, that's where we interpret the most probable answer to be. So you wouldn't run just one simulation of the universe. You would run many. And of course, you would be saying to yourself, well, that seems like a lot of computational power. Well, guess what? You just have to simulate the Earth. Right? Because we haven't left the Earth. Right? Yeah.
If we were like, say we got to the licensure part.
Yeah.
How do you get enough like things and materials to build it?
Very good question. So he is talking about, Christian's talking about this one. How would you build it? Look at how thick it is. 3 meters. Not very thick. So all you have to do is just like, you know, grab all of the asteroid belt, every single piece of the asteroid belt, and maybe like a planet that you don't really like that much, and then you've done it, right? Not that thick. You're trying to. So one of the things that people talk about too on the dice here is likely you would have solar panels on the inside and you live on the outside. Like that would be the new planet, right? Because it'd be warm, space is cold, right? And use the external heat for this person, mixed bag, kind of a weirdo at the end. Really interesting physicist, had all these really crazy, cool ideas that are actually like holding up time. Okay, that's as long as I'm allowed to have you for. If you have any other questions, happy to answer them. Otherwise, I'll see you next Tuesday. I guess I'll remove this as a possibility from the things that you want to talk about next week, unless you just want to do exoplanets. Okay?